Resume our session. So for the last part of the session, we briefly introduced the Java memory model and the garbage collection algorithms. So let's move to the next topic. So this is called thread. So for multi-threading, we need first to know how to create a thread, right? So for a thread, does anyone know how to create a thread in Java? Like how to create a new thread? Any answer to this? Like how can we create a new thread? Mm, yep. We can like extend the thread a thread class. So uh we can extend a thread class. That is one way. And any other way to Yep, that's good answer. That's one way to create a new thread. And is there any other way? Yep. You can provide a runnable to the thread. That's also another way to create a new thread. Runnable. Yeah, you can provide a runnable instance. So these are the two ways to create a new thread. And let me further give you examples of how to create a thread. Like let's call it thread test. So here, what I'm gonna do is I want to use the first way to create a new thread, right? I want to extend a thread class. So here we can, and if we want to extend the thread class, what we need to do is we need to override the run method inside the thread class, right? So, and the run method is the like is the thing we want to execute it when we start our thread. So here, let me just system out this thread's name. Okay, so current thread get name. Okay, cool. And also, like I can create it. Maybe call it test 11. I forgot how many test class I have already created. So here we can, in the main method, so the main method will also have a main thread to run it, right? And so now I will create a new thread based on the thread task I created previously. So here what I'm gonna do is just to use the thread test. Let's call it thread one. And okay, so now we have already created a thread, but the thread is not running yet, right? So we also need to use the start method of the thread to make it running. And only at this time, the thread has been moved into the run stage, and it will start executed. And if we take running, so you see the thread just print out its name. Maybe make it more obvious. My name is, run it again. Yep, you see it prints, suggests that the thread is kickstarted. But if we do not run the T1 started, then the thread just in the new stage, it not get executed, did not running. And also one method I want to introduce is called the join. So if we make our thread to maybe try, because if I directly make like the thread sleep, ask me to like resolve this unchecked exception, interrupt exception. So remember yesterday we talked about the unchecked exception. We have to use try catch block to handle it. Because this run method does not throw any exception, so I can only use this try catch block to do it. Try catch. Why the override method is run but you called start? So actually things is kind of different here is that we cannot directly call the run method. We have to call the start method of the thread and let's check. And you see the start method will call the run method for us. We cannot directly call the run method. Where is the start? You should. Let me see. Catch thread. This method is involved is not involved. Cause this thread to begin executed. So this if the thread was already started, and I think try start 0, and then start 0 is a native method. I think if this thread was constructed using separately one object. I think because this is native method, so it just implemented by other languages. So I think, but we cannot directly call the run method. We have to like just as this method inferred us, we have to use this method to cause this thread to be executed. We cannot directly call it run. But the behavior that the thread is performed is defined in the run method. So we just call the start to let the thread begin to execute it, and then the thread like will itself will like execute the run method, but it just all handled by the thread itself. We just call the start it to start it. So here execution. Uh, should be exception. Here we do not catch anything. We just want to use the check catch block to get our oh, I missed this column. Okay. So we just want to use the check catch block to resolve the unchecked exception in order to get it running. So here, if we do not call the T1.join, I believe we cannot see any result. Why was it? It's kind of confusing. Maybe let me. Okay, so I think what I want to do here is I want to make our like T1 to sleep for 3 seconds, and I think it should not block our main method, and then our main method should execute it first so we cannot see the result. But I'm not sure why our main thread is waiting for our thread 1 until it finished. But there's one thing called join. So join is that also we need to throw the exception. So this join means let the current thread wait until the T1 finish its job. So where did this statement get invoked is in the main method, right? So it let the main thread to wait until the T1 finish its job and join here. So this statement is used to let the T1 thread finished and then like block the main method here until the T1's finish its job so we can see the result. But I'm not sure whether why without this one T1's our main method still wait for T1 to finish it. I'm not sure the reason. Maybe it's some optimizer, uh, it's some optimizing done by the optimizer or some other reason. I'm not 100% sure about this, but maybe let me check it later. So I remember in other examples, like if we do not let the main method wait for the wait for our created thread, it will just the main method will just finish job and then uh, exist. So I'm not 100% sure, but maybe let me figure it out later. And the next way to create a new thread is to provide a runnable instance, right? So does anyone know what is a runnable? Mm, so what is a runnable? Any any answer to this? Runnable also provide run method for thread to execute, right? And that's correct. That's correct. And also runnable is a functional interface, right? So does anyone know what is a functional interface? Uh, function. So functional interface. Yeah, correct, perfect. Yeah, only single one abstract method in the interface. So if one interface only contains one abstract method, it will be a functional interface. But functional interface can have like other default method or private method. As long as it only contains one abstract method, then it's fine. It's a functional interface. And so runnable is one of the functional interface. So it contains one abstract method in it. So what we're gonna do is we will provide implementation for this functional interface, and then later we can instantiate an object from this uh, runnable type subclass, right? Because we cannot directly instantiate an object from the runnable, right? So if we do something like this, thread T1 x new thread, and here we want to provide the runnable here. This is called a lambda expression. So because functional interface only contains one abstract method, right? So we can just directly use lambda expression to work with the functional interface. So lambda expression is like writing a function directly. So this this method will be provide implementations for our abstraction method in the functional interface. So here, let me just write some really simple things like uh, provide I am I am runnable. So and we'll do the same thing like T1 dot start. And running it. You see, it turned out that I am a runnable. So what happens here is that, let me explain here. Like first, um, we are this new thread asks us to provide a runnable type object. So we are using lambda expression to um, lambda expression to create it an anonymous class. So anonymous class, anonymous class. Uh, so the anonymous class is a class that uh, is like a one-time using class. It's not like the previous class. It has a name, and further you can refer the use this class in other place. But anonymous class is just does not have any name. It will be just used one time to instantiate an object. So remember that everything in Java is an object, right? Because Java is a OOP programming language. So here, what we actually provided is an object, but the flow is like this. This is a functional. This is a lambda expression, right? So we use the lambda expression to implement an anonymous class that implement the interface, runnable interface, and then we instantiate object from this anonymous class. So always remember that we cannot instantiate an object from the interface, right? So actually we are instantiate the object from the anonymous class that created. So this anonymous class is, we are using the lambda expression to like implement the runnable interface into an extend the runnable interface into an anonymous class and then instantiate an object from it. So this is the usage of lambda expression. So although you see here you see there is just one lambda expression, but actually there is a underlying mechanism happens here and finally generate an object, and we provide the object here. So how do you pass algorithm to lambda expression? And could lambda expression have default attributes? So you see in the left part, this is just like so the lambda expression should work with the functional interface, right? So we just trying to provide an concurrent implementation for the abstract method in the functional interface. So what we need is just to implement a method. So on the left part will be the method parameters. So, but here, because the run method does not take any input, so here will be just empty. But suppose you're trying to, like, you want to implement another, no worries about this part. I will introduce the functional interface and lambda expression in next week's Java 8 new features session. But let me give some example here. Like if you want to supplier also does not take any input. Maybe let me um let me implement a functional interface. So here function functional interface. Here is the input type, maybe just the integer, and the return type is also integer. So here, what we're gonna do is, if we want to use the lambda expression to give an implementation, like the same flow to give an object of this function type functional interface, we with the underlying mechanism are the same. Still, we use the lambda expression, and then anonymous class is implemented based on this, and then we instantiate an object from the anonymous class. So actually, what provided here is an object. So here we will doing something like we'll have x. So the type is already being determined. So we do not have to provide a type. And here we just like return one, something like this. So this will give us a object. Using this lambda expression, we will get an object just like the float here. Just always keep in mind that everything in Java is an object. Then all the thing you made in Java will be very clear. So here, this lambda expression using this flow created an object from it, and later what you can do is let me rename it func. Okay, so you can just invoke this method that we implemented. So you see, apply, and we can. But this is just a dummy implementation. If we system out this, we will just get the return value of 1 because you see, we are creating a func object, and this func object has a apply method in it, and this lambda expression give implementation for the apply method. So this apply method, as we define, take a x as input, take an integer as input, and also return an integer as output. So we just write a dummy logic return 1, and we can apply any integer number like just here as here defined any integer number as input, and it will just give us one as output. This you see. Oh, sorry. You see. So here is the input, and here is the method body. Is the way to is there a way to pass algorithm to thread? I don't think whenever we all the thing we can pass to the thread is when we define it. Once we define it, we cannot pass anything to the thread anymore. Yeah. Uh, so let me comment out this and also comment out this. And if you feel that this is kind of because we are trying to provide an object here. So if we want to use another way, maybe make you easier to understand is that we can create a runnable outside here. But this is the same. Like we just create a runnable object outside outside our thread creation statement. But we do the same thing. Like use the lambda expression or um, use the lambda expression to system out another implementation. So here you see we have instantiate an object from the anonymous class that implement the runnable interface, right? And so this runnable object is we can we can provide it here like runnable. You see this new thread, when we create the thread, it asks us to provide the object type of runnable. So we just create a runnable object and provide it here. So you will see another implement. So it's quite the same. So because you see, I just want to clarify that this statement is just used to create an object. And if you feel uncomfortable with the lambda expression, we can also do another way to implement this. But this will be this will implicitly implement the anonymous class, and it will be a little more tedious. So you see, we can use this syntax to create an anonymous class directly. So you see, we use new runnable, but actually runnable is just a interface, right? Cannot be directly implemented, cannot be directly instantiated. So we implement an anonymous class from it, and an object will be automatically instantiated from this um, anonymous class. So here, let me system out. I am anonymous class. and we can, it's the same. It's the same. The other logic is the same. We use the directly use the we without using the lambda expression, we use the anonymous class syntax to create the roundable, and you see I am anonymous class. So you see, if we do not have anonymous class, if we want to work with the functional interface, we have to use this syntax. It's a lot of work. But you see, actually what really matters is just the run method, right? Because there is only one abstract method inside the runnable interface. So all we need to implement is actually this little method, little piece of method. So we just introduce the lambda expression to save our code time. So we can, you see, if without the lambda expression, we have to write all this. It's kind of tedious. So yeah, and this is thread and how we create a thread. And also, let me further introduce the life cycle of a thread. So when we create a thread, the thread is not like directly being activated, but it actually, when we created the thread, it just entered a new stage. So a stage called new. So the new stage is means the thread is ready, but we just created it, but we haven't run it. So you see, if we come out the start, nothing happened because our thread just in the new stage. It is not activate. So when we call like start method, it will be activated and start kick running. So it will move to the activate stage. And like the thread running, when we run a thread, is like a one-way road. It's like a one-way road, so it cannot go back. So after we start it, we cannot like restart it. Like we can only start it once. So it's just one time. The thread is one time using. So if we want to start it and we want to start it again, we cannot we cannot do that. You see, illegal thread state exception. So that is because once you start its thread, after it finish work, it will move to the um, terminate state. And once the thread go into the terminate state, you cannot run it again. It just got terminated. So it's a one-time using thread. And before this terminate thread, I further want to introduce a state called um, like wait or block state. So that is when you invoke the sleep method or when you invoke wait method, it will move the thread into a like a wait or block stage. So and so you see here, when we call the sleep method, we actually make our thread test thread to being blocked for 3 seconds, and it will be moved to the wait stage until the timeout, and it will be activated again. Um, and finish after it's finished running, it will go to the terminate stage. And also, what wait doing is kind of different with sleep. So the wait method can only work with the synchronize or with the lock. So why was it? Because wait means you will you have to the prerequisite for calling the wait is that you are holding a lock. And when you call the wait, your thread will release the lock it currently holding. So when you call the method wait, it will release the lock that the thread currently holding. So so if you do not even have a lock, so you cannot be available to invoke the wait method. So, um, but if we call a sleep, sleep won't release it lock. For example, if you are in a synchronized method, you call the sleep, the the thread will just sleep with it lock. It will not release the lock. So when you call wait, it will release the lock, and then other thread can compete for the lock, and when they got the lock, other thread can keep running. But the sleep method won't release the lock. So if in a synchronized block, your thread has acquired a lock, and then you call the sleep, the thread will just sleep with the lock. It won't release it. So other thread need to keep waiting for the lock you are holding. So how does Java know whether the thread is holds a lock or not? That's a good question. I I am not sure whether there is a flag or not that indicates the thread is holding the lock or not. I think maybe there should be some attributes in the thread that should indicate whether the current thread is holding a lock or not. But that's a good question. I never saw this before. So, uh, locker. I think maybe it should be the monitor or other things that let me think about it. Mm, I think maybe if there is no attributes in the thread, then there might be something in the monitor itself, like the monitor uh will record that which thread is currently holding it. I think if the thread does not, let me think, if I have a monitor, but I never tried to do this before. Let me try if I can find it. So if I have a um, arbitrary class, and if I can find the monitor of it, what is this? A state. So thread state for a thread block waiting for a monitor lock. But this is like a enum type state. It's not it's not indicating that which log is holding. Uh, Let me see. Determine whether the Java thread holds. Yeah, maybe let me read this uh, Stack Overflow article later. Thread host log. That's a host log method. Oh yeah, there is a host log method. Yeah, I think this should be something related to this. Let me try. Return true if and only if the current thread holds a monitor lock on a special object. Yeah, I think that should be the way. So when the thread like when the JVM try to check whether your thread is currently holding this object's monitor or not, it will pass this object to you, like the thread holds log of this object, and then it will return a Boolean type that's whether the current thread is holding the monitor of the log of the special object. Yeah, that's a that's a good point. Yeah, cool. Okay, good question. I never like I even never like thought this before. So And yeah, so but one thing you have to be cautious about is that the sleep will not release will won't release the lock it currently holding. Won't release the lock. But wait will release the lock. And later, if you call the wait method, you have to use like the notify method to um, to notify your thread to let it wake up again and to compete for the lock again. And when it successfully compete for the lock, that is to say it acquired the lock again, then it can resume running the code block. Yep. And this is the like several stage for thread. And yeah, this is what I want to introduce for thread. So any questions related to this part? So so if no other questions, let's further move to the volatile. So does anyone know what is volatile keywords? Mm, so volatile keywords mm, is the keywords that you want to use when most of the case is that when you're trying to prone to change that the same to say that that's a good answer. That is the same to say that you want to provide a visibility for an object's reference, right? So that is to say, like suppose you have a like a Boolean flag variable that you made a change to this variable. You want the other thread to immediately like see the changes rather than just read the previously load variables in the cache. So you will provide a volatile keywords to this flag. So in this case, once you change the value, the other thread can immediately see the changes. So this is called visibility. So what does it mean is you have to recall a structure architecture called cache, right? If because we want to like improve the access time for retrieving the data in the memory, we further build a cache on top of our memory. So whenever you trying to access the object in the memory, you will first try to look up it in the cache. So if you do not provide volatile, then maybe for to say like let's say we have a flag variable, then you just look up in the cache. So suppose you have like multiple thread and like other thread may have other cache. So like is there any typo? Maybe just no typo. So when thread one look look in the if thread one like made some changes in the memory, like it changed this flag object, but the thread two is like still reading the cache, and then it will not notify there is a change already been made in the flag. But with the volatile, you will directly force your thread to directly read in the memory, but not read in the cache. So you will read the most up-to-date value. So this is how we use volatile to provide visibility. And also another thing that volatile provide us is called a M fence. So it's a memory fence that you know that the Java optimizer might reordering your code, like not follow your thoughts. Maybe like if I have a code block, like you define int a equals to 1, and I have something like maybe um, Boolean flag equals to true or false, things like that. And you want to make sure that another, and here you want to, let me think, let me think. So maybe we first have a Boolean flag equals to true, and later we modify this flag into false. And after you modify to false, I further want to make the a equals to 10, maybe some code like this. And the if you do not use volatile to prevent the M fence, the JVM optimizer might reordering your code. Like those statements, the the optimizer might move this a equals to 10 prior to the flag equals to false statement. And in this case, if another thread, let me think about this example. I haven't used this example for a while. So if another thread try to read your variable a, and let me think about it. If you reordering those two things, what I want to do is I want to make sure that when the flag been changed to false, the variable like a should already been modified to 10 already. But if the code been reordered, maybe the flag already been like for here, if the code is not reordering, so we can make sure that the flag only be make to false after a is equal to 10, right? But if the GVM optimizer do some reordering to our code, maybe something will happen like this. After the flag make to false, then your variable change to 10. So um, if this thing happened, like let me think what will be the result. Like we want another thread to read our A only when the flag turn to false. Yep, we can do that. And so there will be a risk that if so this is happened in one thread, right? And then we also have another thread, maybe T2 try to read the variable A when the flag is equals to false. So like it was like doing something like if flag is equals to false, then we um, print out like system out variable A. So if the optimizer reordering our code, there is a chance that maybe the flag has already been made to false, but when because those two threads are running concurrently, so maybe there are some other thing delay our changes. So you see, if it reordering our code when the flag goes to false, and we're trying to system out it, maybe we will still print out one. But um, so but actually the code we write is like this. We write a equals to 10 before flag turns to false. So by our design, we always want to print out the variable 10, right? But maybe the optimizer might reordering your code like this. So sometimes you might see a equals to 1, even though you write your code like this. So um, but if this is called the reordering, so GVM optimizer might reordering your code. But I tried this example previously, like by some demo, it does not give the result that I want. Maybe the optimizer is smarter than I think, so it won't it will detect those like behaviors and maybe prevent those reordering, but theoretically it will sometimes it will reorder your code, and sometimes you should give the false result. So, but by using the volatile, like if you make your variable a to be volatile, but in this case, this should be like a data member and other things maybe in the method or something like this. And if you provide it to be volatile, then this if you give a keywords volatile to this variable, then you will provide an ampersand to the to your program. So it will make sure that what right before the volatile variable will be executed first, and then the rest of them will be executed later. So it will prevent reordering. So because we have this fence, like it will separate our code, like uh, before it and after it. So in this fashion, like by this feature, fence, we can prevent the reordering of our optimizer. So this is called this is another feature that volatile keywords provide us that prevent reordering. Uh, so this is volatile. And because this feature I tried myself with some demo, I did not see the desired output I want, so I won't give a example for this, but at least I can give an example for the visibility to make you have a more concrete sense for the visibility. It's like we can have a we can have a Boolean flag, maybe equals to false. And uh, here in the PSVM, in the main method, we will have a thread, maybe thread T1, try to modify our flag, like in the new thread. Or we will modify our thread in the maybe we just modify the flag in our main thread. Maybe flag equals to uh yes. What is the non-static? Okay, let me just make it static. Static. Okay. So here in our thread T1, we want to do something is like um, if the keep while the flag is not equals to true, I want it to keep for loop here. And then after the flag change to true, it will get out from the while loop, and then we can system out. I am out. So here in the main thread, so remember that now we have two threads, right? One is the main thread and one is the T1 thread. And the T1 thread is always check always check the flag variable, right? When the flag variable tends to true, it will system out this statement. And first, let me make our main thread sleep for a while. So sleep. Maybe make it sleep 3 seconds. So, and later we will change it to true. So now we do not provide volatile, right? So, and also we want to start our thread. So, what I want to do here is that maybe I have to start it before we make it sleep. So what I trying to do here is like we start the thread one, and what we want to see is that after 3 seconds, our main thread change the flag into true, and after 3 seconds, the thread one should detect the changes of the flag variable and later like print out this statement. But if we do not provide volatile, we can see that like 1, 2, 3, 4, 5. You see the T1 thread just keep running, and never print out and exit. So this is because the T1 is continually reading the flag variable from the cache. It does not see the changes here, but we can provide volatile here, and then we can run again. You see, after 3 seconds, it print I'm out. Yeah, you see again, there is no problem. So this is when we should use the volatile. So if we want to first, if we want to the most commonly seen reason is that when you want to provide a visibility, that you have those variables shared by all the threads, and you want other thread to read the most up-to-date data rather than like if we remove this, you see it just to keep waiting for the changes, but it not read directly from the memory, so it does not notice the recent changes. So um, if this is the case, we will want to use the volatile. And also, in some cases, maybe you want to prevent the reordering, then maybe it's a good reason to use volatile. So this is volatile. So everybody good with this part? Okay, no problem. Um, so if no questions, let me give one question for you guys. Like, um, can we just use volatile to provide thread safe? Like, is volatile itself like sufficient for thread safe? Yeah, correct. No. Like, because the volatile just to provide the visibility. So, um, for example, if we have a volatile integer number and we're trying to increment it, there will still be like something called race condition. We can give an example here. So, but there is one thing that I will introduce in tomorrow that called CAS, that is compare and swap, or compare and swap, or the same compare and set. Those are terminologies that equivalent compare and set, compare and swap. So the CAS plus the volatile, then it will be thread safe. But volatile itself cannot provide thread safe. So for example, if I have a um, so the race condition is one thing that, for example, if you have a thread T1 and also have a thread T2, when and also you have like a shared variable int int variable A or int variable I, um the, at the beginning the variable is equals to 1, right? So your thread 1 will read it. When you read it, they read it at the same time. So thread 1 will read the value of 1, and thread 2 will also read the value of 1 at the same time if they read the value at the same time. And they both of the thread are trying to invoke an increment method to increment this variable I value by 1. So when you write it, there is a high chance that because you both read the same value, then when you increment it, you write 2 into I, and also the thread 2 also write 2 into the thread into the variable I. This is not what we want, because and also this is called a race condition. So actually what we want is that when thread 1 increments 1 to thread into variable I, and also thread 2 increment 1 to the variable I, we want to see the result of 3, right? We want something like this, like if thread 1 successfully add value to 1 and increment it to 2, then we want maybe when it's thread 2 to increment it, we want it to maybe to fail this increment because the variable has already been changed to 2. When you're trying to increment it, it should fail, and it should like read it again and read the new value 3 and then set it to read the new value 2 and then set it to 3. So this is the actual correct result that we want when they both trying to update the variable I at the same time. So they both want to increment the variable I at the same time. This is the actual result that we want. So if something happened like this, they both update the variable I by 1 and they both write it as 2, then this will be called as a race condition. So let me give you an example to make it clear, like test race. So for here, we will have a static method called add1, maybe. Let's call it add1. So here, this method, also we need the static int I, right? And what we want to do is we just want to increment this I by 1. Uh, okay, so, and in the main method, we want to create 2 threads. Thread T1 and we will have a runnable try to invoke this add1 method 10,000 times. Oh, int less than 10,000. And we want to invoke this add1 method. Also, for this thread, we also have a thread 2 doing the same thing. Add 1, invoke this add1, that's increment variable I by 1 10,000 times. So the desired result that we want to see is that after this T1 started and T2 started, what we want to see is also, oh, maybe here I can see the result of join. Maybe let me test it later. So I think here we need to join it first. Otherwise, if the main thread just directly print out, you see, sorry, throw exception. If we just directly print out here, maybe the T1 and T2 haven't finished it, and then we just if something like this is not what we want, like this thread just running in parallel with our main thread, right? So you see, just those two threads haven't finished yet, and we just print out the I. So here is a good example for the join, right? So we have to first wait this two thread to finish its job, and then we system out the I. So after it finished the increments, after wait it finish its job, then we block our main method here. After it finish, we print out I. But if we do not provide any thread safe implementation, you see the ideal result should be it will be 20,000, right? Because we incremented separately by 10,000 times. So the ideal result should be 20,000. But why the result is not the 20,000 is like I said before, like in some of the addition, they happen in the same time. So they both think the I is equal to some random value, maybe 101, 101, and then they just both update the value based on this old value. So they got the same results. Update the I both into 120 and 102, but it's not the case. Actually, they are increment the 101 twice, so it should be the final result should be 103. That should be the ideal result. So if something like I've said previously happened, then we cannot get 20,000. But if we can make sure that every addition is correct, then we should see the result 20,000, right? So as I mentioned previously, that just to provide the visibility is not sufficient, right? When you run it again, you see it still have the race condition. The reason is that although they are able to see the most up-to-date value, you see, they both able to read the most up-to-date value, but when they update it, they do not have any check for it. They do not secure that when they update based on the old value, their updates are correct. So maybe they are both update based on the old value, and so there will be a miss addition increment for this value. So even though they are reading the most up-to-date value, you still do not secure the thread safe. So volatile itself cannot like itself cannot secure thread safe. But one thing, so is there any way that we can do to make sure that this implementation is thread safe? Any any idea that how can we modify our code that we can get a result of 20,000? Any idea like how to do this? Yeah, yeah, yeah. We can use lock. So synchronize is yeah, we can use synchronize. Those both are good answers. So synchronize it just it just work as a lock. So we can just here we can just use no synchronize. Here we can just synchronize our add one method. So in this case, when we run it again, we can get the 20,000. So why was it? This is because the mechanism of the synchronize. So you see, this is a static method, right? So when the thread try to execute this method, it will try to first acquire the lock, that is the monitor. So when we synchronize a static block, the monitor we are trying to get is the class monitor. That is the class monitor of this test race. So if we are trying to synchronize an non-static method, then we are trying to acquire the monitor of that instance. So in this case, let me first illustrate what the class monitor is. So you see, the static method is belongs to the class itself, right? So when this two thread, when they try to enter this, when they try to execute this method, the requirement is that they first had to acquire the monitor of the class. So, and there is only one monitor for this test risk class. So that makes sure that at the same time, there's only one monitor. So at the same time, only one thread can successfully obtain the monitor and then enter this method and add one to it. So with this synchronize, we are making sure that our add one method is critical. That means at the same time, only one thread can execute it. So in this case, like the previous one, when the thread one successfully acquire the monitor, then it will like try to invoke this method and add one to the variable. At the same time, the T2 will be blocked because it does not successfully acquire the monitor, so the T2 will be blocked. And when the T2 get the monitor, it will like read the new value of 102 and then increment it by 1. So this means at the same time, only one thread can execute the method. So in this case, there will be no race condition because race condition means at the same time, two threads are invoke this method, right? But with synchronize, we make sure that there's only one monitor and only one thread can acquire the monitor. So make sure that only at the same time, only one thread can execute it, and then make sure that those increments are like serial one by one happens one by one like a serial happens sequential. So um, this is why we can get the 20,000. So, but one thing that uh, you see, it work with monitor. So if synchronize static block, we acquire thread try to acquire uh class monitor. And suppose we are like we have a let's say this maybe let me think how to let me create another add one method that sorry, another void add one method but non-static. So it should also increment by one, but it's not static. And we also synchronize it. In this case, we are synchronize a non-static block, right? A non-static method. So in this case, when a thread try to execute it, it will try to acquire the objects that it tried to acquire the monitor of the objects that invoke this method. So what does it mean is you see when you try to um, directly write this, you see non-static method cannot be reversed from static, right? So you have to um, first create a test race object, tr1 equals to okay. And also I have another test race tr2. So in this case, if I invoke the add one noun from tr1 and invoke the tr2 add noun, uh, when I run it, it should not provide thread safe. You see, you still have the race condition. So why is that? That is because when you synchronize a non-static block, it's trying to acquire the monitor of that object. So you see, we have two objects. One is called test race 1 and another called test race 2. So here, the thread 1 is keep trying to get the monitor of this object, and thread 2 are trying to get the object of this test risk 2 object. So there will be two monitor, like one monitor of the TR1, one monitor of the TR2. Those two monitor are not blocking each other. As I said before, the synchronized mechanism is just like the thread that successfully acquired the monitor that can execute the method, right? So if there is two monitor and they are trying to acquire the two different monitor, then they will not block each other. Like thread 1 will successfully get TR1's monitor and execute it, and thread 2 will successfully get the TR2's monitor and execute it. So they are not blocking each other. So um to to make sure that they are competing for the same monitor and make sure that this is a critical block, what we can do is we can make sure that they are invoked by the same object from the same object, like TR1 and TR1. So in this case, both of the T1 and T2 are trying to acquire the monitor from trying to acquire the monitor of object TR1. In this case, you see, there will be no problem. We can get the 20,000. Yep. So this is the difference between when you synchronize the non-static method or synchronize the static method. So if synchronize non-static, the object monitor is acquired. Uh, okay. So this is for synchronize. So any questions related to this part? Related to this part? Like related to the synchronize keywords? Hmm. If no questions, then I think we can stop here and let's meet tomorrow at the same time. And if you have any questions, just feel free to ask me. Maybe you can just direct message me in the Zoom chat or like in the Zoom channel, or you can just ask me now. Can you share the note? Yeah, I think yeah, absolutely. Every day after the session, I will share every day's notes after the training session. Yeah, no problem. Um, yeah, so if no questions, then you can feel free to leave the meeting now. Yep. And if you have question, you can just ask me. If you want assignment, yeah, sure. I will give assignment for today later. Yeah, no problem. Thank you guys. Have a good day.